Welcome back to another installment on lines. Let's get started. If you notice, I don't want to read through the problem, but if you have read it, you see this is an extension of the last problem on the previous video, right? Where you were given an equation and a set of ordered pairs. In this case, you're not given an equation. Instead, you're given a set of ordered pairs for both equations, and you're told that both equations are parallel, and you're asked to determine the value of x in one of the ordered pairs. So here's how you do it. If you want to pause the video and work on your own, that would be great. I would highly suggest you do that. So for line J, okay, the ordered pairs are 1, 3, and 2, 4. So that would translate as x1, y1, x2, y2. So the slope will be 4 minus 3 over 2 minus 1. So that's essentially 1 over 1, which is 1. And line K, the ordered pairs are 0, x, and 10, 3. So that would translate as x1, y1, x2, 2. So slope will be 3 minus x over 10 minus 0. That will be 3 minus x over 10. Now, what did we say as a condition when two lines are parallel? That means the slopes are equal. That means the slope of J equals slope of K. That means 1 equals 3 minus x over 10. So if you multiply by 10 on both sides, then we get 10 equals 3 minus x, which means 7 equals negative x, x equals negative 7, right? So the answer for x is negative 7. Does that make sense? All right, let's continue. Line L is represented by an equation, and if line M passes through these points, and if M and L are parallel, what's the value of A? Now, this is very similar to the last problem in the previous video. So first, let's convert this 2x minus 3y equals 4 into the appropriate slope-intercept form. So we can subtract negative 2x on both sides, which would give us negative 3y equals 4 minus 2x. And we can divide by 3 on both sides, which would give us y equals 4 over 3 minus 2x over 3. And we still have this negative. So you can multiply by negative on both sides, which would give you y equals, sorry, I meant to say an arrow. So y equals negative 4/3 plus 2/3 x. So if you write it actually into the proper expression like you're used to, y equals 2/3 x, negative 4/3. We're not worried about the intercept. We are only worried about the slope. So m equals 2/3. Because lines L and M are parallel, slopes are equal, right? So that means instead of an equation, you're given a set of ordered pairs for line M. So you can convert that into the slope form. So 1, 4 and 2, A. You can call this x1, y1, x2, y2. So slope equals A minus 4 over 2 minus 1, which translates into A minus 4 over 1. The slopes of the two lines are equal. So 2/3 equals A minus 4, right? You can multiply by 3 on both sides, which would give you 3a minus 12. And that means you can add plus 12 on both sides, which would give you 3a equals 14. So a equals 14 over 3. Does that make sense? And that's pretty much it. Let's continue. Which of the following line is parallel to y equals 0.75x plus 9.5? I would say this is probably the easiest question in all of the problems in this entire series, right? We're told that the two lines are parallel because you're told which of the other line is parallel to the line that's given. So here you are not going to do any workout. We're simply going to use the answer choices to our favor to determine what will be that line be. So we know for the first line, y equals 0.75x plus 9.5. Trust me, I've spent more time talking about it rather than the time I'm going to actually use to solve the problem. The slope here is m equals 0.75. Because the two lines are equal, the slopes have to be equal. And right away, we see there's only one line, one choice given here where the slope is even 0.75, and that is also a positive 0.75. So that is the correct answer. Two lines are described by the equation, and you're given a set of conditions for the answer choice. So first, what we need to do is to convert each of this equation into its appropriate slope-intercept form. The first equation is already in its slope-intercept form, so we don't need to even mess around with it. So its first equation can be retained as it is without any change. And we know the slope here is 3. Now let's take the second equation, 5y minus 25 equals 15x, right? Now let's add plus 25 on both sides. So that'll make it 5y equals 15x plus 25. And if you divide by 5 on both sides, then 5 equals 3x plus 5. This is equation 2 in its slope-intercept form. Now, if you notice, not only is the slope the same, but the intercepts are the same, right? Now, when you say two lines are parallel, we are implying that only the slopes are the same, the intercepts are different. When we say two lines are perpendicular, that means their intercept will also be different and their slope will be a negative reciprocal. But in this case, the two equations are mirror images of each other. That is, they're exactly the same. They're identical. That means identical, there's an alternate way for it, is same. So these two equations represents the same lines. So same lines means same slope, same intercept. Parallel means only the slopes are equal. Perpendicular means the slopes are negative reciprocal to each other. Okay, all of the following systems have exactly one point of intersection, except first you need to understand what the question is asking. It's asking there's only one set of equation pair that has multiple points of intersection, right? Parallel lines generally have multiple points of intersection. Perpendicular lines have only one point of intersection. So if you figure out which two equations within a pair has identical slope, then that is the correct answer, because parallel lines have multiple points of intersection. The question is asking for one point of intersection. So what you do, or what you're essentially doing, is figuring out two equations that have identical slope. That means if they have identical slope, that means they are parallel. That means they have more than one point of intersection. Right? So if you write these two, and if the slopes are not even the same, then also you can disregard it, just so you know. So we have 2x minus 3y equals 4. This may be a lengthier problem unless I know the answer to it, and if I do it, then you might think I'm just copying the answer, but I want to actually work it out. So this is already in the slope-intercept form. So if you convert this, then it'll be negative 3y equals 4 minus 2x. And clearly we know that we're not going to get the 2 as the slope here. So y equals negative 4/3 plus 2/3 x, right? So clearly 2/3 and 2 are not the same, right? If the values are not same as well, then also that is not the correct answer, right? They have to be identical for it to be having more than one point of intersection, which is precisely what the question is asking. So this is incorrect. And clearly, this is just not going to give you the correct answer. Well, let's not take any chances. Let's actually work it out. The first equation is exactly in its form, so let's not mess around with it. Let's just manipulate the second equation. So we know 5x equals 5y minus 5. We can add plus 5 on both sides. So 5x plus 5 equals 5y, right? Clearly, if we divide by 5, then it's x plus 1 equals y. If you notice here, the slopes are negative reciprocals. One reciprocal is 1, but the key here is negative. So these lines are perpendicular, but we're looking for parallel, so that's incorrect as well. So let's go ahead and do the next one. If this turns out to be perpendicular by default, this will be the answer. If this were, you know what I'm trying to say. So let's do 2x plus 4y equals 7. So that means 4y equals 7 minus 2x, and y equals 7 over 4 minus 1/2 x, right? Similarly, we have 2x minus 4y equals 7, negative 4y equals 7 minus 2x, y equals negative 7/4 plus 1/2 x, right? Again, you noticed this is not a negative reciprocal, and they're just completely different slopes, right? That won't work either, right? As I said, it has to be exactly the same. So this won't work. So this is incorrect. So by default, this will be the correct answer. So let's see if these values are actually parallel, because that's the moment of truth that we've been waiting for. So we have 4x minus 3y equals 2. So negative 3y equals 2 minus 4x. Y equals negative 2/3 plus 4/3 x, right? I'm just dividing by negative 3 to make my life simple. Similarly, we have 6y equals 8x plus 9. If we divide by 6 on both sides, 8 over 6x plus 9 over 6. We're not worried about the intercept. We're just interested here. So this is 2/4, this is 2/3. The slope here are identical. That means they have multiple points of intersection. So the only system of equations that is the correct answer would be choice D. Do you see what I did? Okay. This may be a lengthier problem on a test. Of course, with experience, you may be able to do elimination pretty quickly to narrow down 1 or 2 choices, but ultimately you still have to figure out at least one more choice. So you may have to invest some time. So keep that in mind. All right, this problem marks the end of this video. So line Q is given by the equation 2x minus 3y equals 4. All of the following lines intersect Q except. Now, when does a line intersect another line? Only if they are perpendicular. So we're looking again for an equation that would result in an identical slope. That means the 2 lines run parallel to each other, right? So first, let's actually convert the given equation into its appropriate slope-intercept form. So that will be negative 3y equals 4 minus 2x. So y equals negative 4/3 plus 2/3 x, right? So we know the slope for this line is 2/3, right? So which of these lines would give me a slope of 2/3? So let's go through one at a time. So let's do negative 6y, 4x minus 6y equals 8. So negative 6y equals 8 minus 4x. So y equals negative 8 over 6 plus 4/6 x. So this is 2, this is 3. So right away, we don't even need to go any further. We've already got, this is not asking for multiple choices that are possible. It's only asking for one. What we are looking for is all of these lines intersect each other, except that means there's only one equation where the line would run parallel to the given line, which means they would have to have identical slope. Clearly, this particular line has identical slope to the line that's already given. So these two are running parallel to each other. So that means what we're saying is 2x minus 3y equals 4 is one of the railway tracks. The other is 4x minus 6y equals 8. These two tracks would never touch each other. So the correct answer is 4x minus 6y equals 8. And that is it. Thank you for watching. I'll see you with another video on lines. So please stay tuned.